Welcome to the course Algorithmic Design. Now it's a perfect time to enter into Rhinos. I will not really explain how Rhino works. For that, you can consult some tutorials. I can also, if you have problems, if you never used Rhino before, or for any reason, you can tell me and I can give you some maybe good links or resources to learn. But I will basically not really show you how Rhino works. I will just assume that you are familiar enough that you know. And yeah, I will just kind of work maybe from the top here. And yeah, and the first thing that we will do, we will open the editor. So if you know, if I put in Grasshopper will open, but we will be working in Python editor. So there's edit Python script. So this is the most important command because that one opens your editor. You can probably access it somehow from the top. I just don't know how. Okay, and now I'll just order it a little bit. This one is on the right. This one is on the left. Great. And I'll just turn off this grid that I have here. In my Rhino settings grid, maybe this one here. Okay. Okay, so this is my Rhino screen, and this is my Python editor. And you can see there's already some code here, which I used from before, but you don't have to worry about that. This is basically how your code will look like in the end. This is, if you remember, a for loop. This is how the indents are done, so either with spaces or with tabs. If you write everything correctly in this editor, then Python will kind of color code things. So this is the name of the library. This is the name of the function in the library. So there are kind of different colors for different things. You can see here the string variables are red. Normal numbers are like kind of bluish, or what is this? Hard to say, purple. Comments are green, but I don't have any comments here, but if I put a comment here, it will become kind of green. So everything is a bit color coded. This is not really a good Python editor, I must say. Autocomplete sometimes works, sometimes doesn't. So, you know, they could do better, but this is just what you have to work with. Okay, and I will actually turn off all of these that I have here. And you're left with like an empty canvas or here. And before we go in, I just want to explain very few things here. This arrow here you use to run your code. And that's more or less it. You just run your code here. And under tools, options, there are some paths here that you should just leave them as default, but basically these are the so-called module search paths. Also, your Rhino will look for, or Python will look for, it will look for Python libraries that are installed in these folders. But we will be using only standard libraries that are already installed that come with Rhino. So we don't really need to install anything. And we will be using our own modules. So I will sometimes give you maybe a module, which is just a Rhino file, sorry, just a Python file, which you will keep in the same folder. And then you don't need to even define it here, because additional to this, the modules that are in the same folder where the file is will also be checked. But sometimes if you have a problem running a module, you have to kind of add the path here. Okay, some text editor stuff, you can change the sizes of text and so on. So it's kind of here. This is a very simple editor. Okay, and another important thing is if you go under help topics, here you will get all the functions that you can use in this rhinoscriptsyntax. Also, Rhino comes with its own Python library that enables you to communicate with Rhino functions. That's kind of the connection between Python that you write here and Rhino is the rhinoscriptsyntax library. And again, if you go help topics, you actually open that help, and here you will see, I don't know, like 1,000 plus functions. All of these can be used. And of course, I don't even know all of them, but you know, point is here somewhere. It has to be point. Maybe it's add point or something. Yeah. Okay. There's a function called add point. If you click on it, you get a syntax. It tells you what the function is doing. Add point object to the document. These are the parameters of the function. So what you need to, so what are the input parameters for the function, and it also tells you if the parameter is optional or mandatory. So if you need to provide it or you can just leave it empty, then there's going to be some default value coming in. In this case, this is mandatory, so you have to give it some coordinates of the point. It can be either a point 3D or list of XYZ values. And then you have here the return. So what is the function returning? And here you then have a small example. So you can basically just copy paste this code and just put it. I can just, let's just take it in, hop, copy, go back into Rhino, paste, and I can just run this. And here a point is added to my Rhino. Okay, so we'll go to this library soon, but basically this is your reference. Also, if you want to do something in Python here, you can just go into this help and try to find the function for it. So here we found add point. There are many other functions, and here there are some kind of functions that are maybe related to this one here. So like add point cloud or add multiple points or calculate area and so on. So all of these are nicely explained, and there is there's a kind of small sort of example that you can usually use straight or directly. Okay, that's it. Just add point here. Okay, so you can kind of play around by copy pasting things. Okay, but let's start actually building up. The first thing that we will do here, we have to import some libraries. Also, in order to do anything, well, we can just write Python code here. Also, I can just say, same as did here. I can say a equals, I can create a empty list of some numbers. So the syntax is the same. And then I can say, print a. But I need to save this as a Python file, otherwise it might not work, but actually it works. But I can just save this, or I can go save files, save as, and I'll just now try to find my folder. So I'll give you this file later, courses, algorithmic design, tutorials, and there's going to be session 2. And I usually like to add a date. So there's a 210309. And I will say, let's do, what should we do? Let's call them random numbers, okay? So we can just add some random numbers. Let's do that as a first example. Okay, so now this is a Python file, and I can just run it here. Or it's the same as in the Google Colab, except that here I don't have these cells, so it's just like one long code. But the syntax is the same. There's some difference in syntax, which should not bother you, but some very small details are different from Colab and here. But for all of our purposes, this is basically same Python. Okay, so let's create some random numbers, and this we can do by importing. So at the beginning we have to import some libraries, or so we can import this. If you remember, rhinoscriptsyntax. So import, we say rhinoscriptsyntax, and I should get it as a autocomplete here because it's one of the modules that Rhino is offering. And here I can rename this library. I can say as rs. So this is just how we will start always, because at the beginning, basically this library enables us to access all the Rhino functions. Because this is a very long name, I will rename it as rs. So that's how we will use it. And okay, and actually there's one other library which we'll import. Rhino. Rhino.geometry as RG. So all our code will always start with this. Rhino geometry. So rhinoscriptsyntax gives us sort of functions that you see here. But all these functions are part of the rhinoscriptsyntax library, but there are more functions. Okay, so there's something called RhinoCommon. So that's kind of that is basically the code that runs Rhino, and we can access it directly through this Rhino library. And then we are accessing this like a module of this Rhino library called geometry, and we name it RG. So there's RS and RG, and this we will again just use for every one of our scripts. You can also see all the examples that I will give you. They always start like this. And now we have some useful things that we can use. For example, I can write in RG dot, and now I can access all the functions that this Rhino geometry offers me. For example, point 3D. I can define a point, or I can define it by writing variables by adding coordinates here. So I can define a point 3D in this way, and I can then use rs dot add point, and I can just here I can say this is some kind of point equals. So there's a variable called point. It is Rhino geometry object point 3D, so it's some point. These are the coordinates of the point 0, 0, 0. And I'm using the rhinoscriptsyntax library, so a function called add point. I will add it to my Rhino canvas. Okay, actually this is this file, I call it random numbers, but I can just I will call it different. I will call it just add point. Okay, so this, the only thing that this file will do will just add a point to Rhino canvas. Okay, if I run it, you can also run it with F5. You can see now there's a point here, and yeah, if I change the coordinates, I get a point at a different location. Where is this 100? Ah, it's here. Okay, so now I have 2 points, and Rhino is not deleting anything, so it's just adding. Rhino is adding things as I'm writing. So if you want to kind of, you can just sort of delete them from the Rhino here. Okay, so only 1 point is added. If I run this code multiple times, I'm going to get more points. So if I click here, you will see that there are now 2 points here. Okay, so yeah, so that's a very simple code. Just adds 1 point. Okay, so maybe we can leave it here. Let's create some grid of points, or so I can just save another version, add point. I can say add points. Well, I would just say create point grid. Okay, let's create a grid of points. So for that, you know, a manual way of doing it would be say, well, there's 1 point, and then I'll add kind of another point on another location, and I will add that one. Or now I have 2 points. But this is, of course, very manual way of creating points. I would maybe want to create a grid in one go, or so I'll create a small loop. If you remember, I think last time I showed loops, I can say for, and then whatever, some I in range. Range just creates a range of numbers, so maybe 10, so it's going to be 10 by 10 maybe. And I will create actually a nested loop, or I can actually say here, well, let's not call it that, let's call it X and Y. Or so I'm creating now a nested loop, so 2 loops, like one loop within each other, because I'm creating a grid. Create point grid, yeah. So in range and 10, and yeah, I can just copy paste this one here. I have to be careful with the tab. So in Python, these tabs are important because they kind of show they're basically showing, they're kind of creating a hierarchy of code. Or so I can write like this as well. So I have the first loop, and everything that is underneath is part of that loop. So whatever is underneath here will be executed 10 times. Okay, so but there's another loop inside. So there's so this loop here will also be executed 10 times. So I have 10 times 10, that's 100 times. Whatever is inside here will be executed 100 times. Okay, and I can create my point, and now I have this X and Y which are changing in every iteration. X will be 0, 1, 2, 3, and so on. And Y will also will change in every iteration of this loop here, and it will become first 0, 1, 2, 3, and so on. So I can use these numbers now directly to be my X and Y coordinates. Or so I can just have X here and Y here, and maybe Z is 10, 0. And I can just add this point. Okay, so this will create a very simple grid, 10 by 10 for me. If I run it, you can kind of see how it's created. It's a bit slow. Do it again. If you run it, up, up, up. Okay, so yeah, that's it. So there's create point grid. I can actually, so I'll just save it, create point grid, and I can just call it 2D. Okay, so this grid is 2D, and it's 10 by 10. And now they're kind of created. I'll actually go here under tutorials and just how to keep these files a bit ordered. So maybe point grid I will just delete. Okay, so point grid 2D creates a two-dimensional grid. So if I go into space, into perspective, is just a plane of points. And that's already great. And I will now create a new file which will create a point grid 3D. So I do this the same way. I just add one more level. Or so I have X, Y, and I go down and I create X, Y, Z. And now I want to indent these ones, these two, so I can just select them like this and just press tab to go in. Okay, so now I have 3 levels. And then I use for point 3D, I use X, Y, Z. Okay, so my point will become a point 3D, which is like an object. It is like a point object. So again, when we talk about object-oriented programming, this is an object. Okay, so this is how we define an object, and this object is now stored in this point variable, and we can use it then to draw an actual point in Rhino. And I can do different things with this point later, so I'll just show you maybe later what does that mean that this is an object. Okay, but I just want to use this to create a grid of points. I just run it. Now this will take a while, just because it's the way the Rhino draws. Basically, every time I run this add point, it kind of redraws the whole canvas, which for 10 times 10, this is 1,000 times, is unfortunately a bit slow, at least on my laptop. I can speed this up, or so I can create this faster by, I can add it at the beginning. This is a bit of a hack or workaround, but bear with me. I can say rs dot and enable redraw, and I can put it to false. Okay, so again, I'm using a Boolean variable called false, or Boolean variable false, to kind of deactivate this redraw or with this function. And again, if I want to see what this function does, I go into help here, and here I can find it, enable redraw. Okay, so it's here enables or disables screen rendering, or so that, and I can just add it. There are only 2 options. It's either true or false. And so it's a Boolean variable, true for enable, false for disable. And if I put it here, this will mean that Rhino will not redraw, as long as this script is executing, it will not redraw the canvas. And it will only do it when the script is done. So when everything is kind of executed, it will just redraw it once. And this will make this whole code faster. And if I run it now, you will see what I mean. Up, here it is. I got it kind of in one go. So this should be also on the top somewhere. Yeah, very useful if your kind of code is, if your kind of drawing is slow, then you can use this to kind of speed it up considerably. Okay, so create point grid 3D. So simple loop, and that's it. And now I want to go back. I want to go back and show you some, maybe something like, I'll just say create point. Okay, so I just want to show you a little bit. If I go back, when we talk about objects, I can go Shift Tab to go backwards here. Okay, so I can create a point, and this point has some coordinates. Maybe it's 10, 20 minus 10 or something like that. So these are the coordinates of the point. I can also do them, yeah, okay, like this. and I can kind of draw it, but I don't need to necessarily draw it. I can, for example, I can now ask certain things of this point. So this point is an object. So I can say here, point variable is an object. Okay, so I can say points, and there's an attribute in this point which is called x. Or so I can, for example, print here. I can print what is the point x. And of course, this point x is now just, it is the same number that I put in here. So that's really not that amazing, because that's just a number that I put in. But it's important to know that the point is an object, and this object contains, certain information. Now, of course, point is very simple, so there's not a lot of information to store. But I can save kind of x, y, z. There's even, I can ask what is the origin of the point. Okay, actually, I guess point origin is the same. Yeah, I mean, the point and the origin, of course, they're kind of the same thing, because the point doesn't have any extra information except its origin. But for example, if I have a plane, I can define, plane through two vectors, and then I can also meaningfully ask kind of what is the origin of the plane. Okay, so this is a little bit long way to say that basically point is an object. And I will now go back to the previous example that I had here, random numbers. Okay, so these are now interesting. I want to create some random numbers. Okay, so for that, I will import Python library called random. Okay, I think it should work. If you run it, it should kind of execute without complaining. Okay, and random has a function inside called uniform. Also, every time I put a dot in, I'm kind of accessing the module. So if it's an object, I can access its attributes and methods. And if it's a library object, then I can access the sort of functions or of the object if I put a dot in. So random library has a function called uniform. Uniform, yeah. And uniform gives me a random, says here, there's like a small help. Uniform says here, get a random number in the range from between A and B, depending on the rounding, okay? So I can kind of put 0, 100, okay? And maybe I can say, well, there's some variable x, and that's my random number. That's a random number between 0 and 100, okay? And if I say print, what is my x now? I will every time get now a different number. So this is a number between 0 and 100. And every time I execute, I'm getting a different number here. It's a bit small, but okay. Great, so that's a random number. And of course, I'm using already a syntax x, y, z because I want to use them as coordinates. Or these numbers are going to be my random these are going to be my random coordinates. I can actually just print it like this, x, y, z. So I want to print these 3 random numbers. Here they are. First random number, this of course has a lot of decimal points, but I can also kind of round it if I want. Second number, third number, okay? And if I use these as coordinates, I can get a random point. I can get the point at the random location. So I can say these random numbers, and I can now create another file which will be called random points. Okay. Okay, so I want to now create a point that has these random coordinates are. So I can say for maybe I in range. So I'll do this 100 times. What do you do 100 times? Well, create random coordinates, random numbers x, y, and z. You can print them, but that's not really that important. I want you to create a point which is of the type point 3D. And this point 3D will have coordinates x, y, and z, which are my random numbers, which I defined before, and then just add this point, add point, just add this point to Rhino. Okay, so now we will get a random, we should get 100 random points inside like a random cube. Up. Okay, and we have again the same issue. If I run it, you can see how they are kind of appearing here. And each time they will be different. So if I run it again, I'm going to get 100 points that are at different locations. And I can just kind of keep on adding them. Okay, and again, if I want to make it a bit faster, I can say rs.enable redraw false. Okay, so now it's just going to be a bit faster. If I run it, you can see now they're just appearing on the left. Up. Or if I'm, of course, lazy, I want to be very fast, I can just say here, well, do this 100 times. Of course, this number here and this number here, they're not connected. This is the bounding box, the size of the box. And this is the number of points that I will get. Or so the range controls how many points I will get. Okay, so this is now 1,000 points. And it's kind of easy to see that you know, they all form this, they kind of form sort of like a cube, or like a random cube. And the reason is because this domain, or this domain, it goes, x goes from 0 to 100, same as y, same as z, so it's a positive quadrant, and the points cannot really leave this space, so they're kind of this almost like acts a little bit like a box. Okay, and maybe I want to show it a bit differently. I can just kind of select all the points here. I can say, what can I say? Can I say sphere, center of the sphere? Okay, up. I don't know. I'm just saying again, center of the sphere. Can I do quickly spheres here? I cannot do it. Okay. We can do it over Rhino. I want to just add like small spheres on the where these points are. But that's not really that important. Okay. Okay. So these are now just like completely random points. So there's like a kind of cloud, and I would like to kind of show you. I would like to just show you a little bit. Let's say we want to create a random walk. Or random walk is basically I want to create a polyline that goes sort of zigzags through this cube. Or so I want to have some random steps. Okay, so this is maybe what I would want to create. Now there's a sort of a quick way to do this, which is incorrect, and there's a proper way to do this. We'll first do a quick way, which is incorrect. So I just want to create random points, and I want to connect them with the polyline. Or so these are random points. I can just say random polyline. Okay, so I'm going to now create a random polyline. So these points here, I can use them as endpoints or as a path points of my polyline. So if you know in Rhino, I can write a polyline, I can draw a polyline. There's a polyline here, and I just need to give it points. If I give it points, I kind of create like a polyline curve. It looks a little bit like this. I can use these points as a kind of waypoints for my polyline. But in Rhino, there's a function called add polyline. It's here, add polyline. Now this polyline says here adds a polyline curve to the current model, and I need to give it points. And the trick is that I need first to create all the points, and then I can run this function at the very end. I can run this function only at the very end to create the polyline. Or so it's here. So I need to somehow store these points before. Or so at the very end, I can say, you know, polyline equals, or now I can just say rs.add polyline, and I need to give it some points, so some list of points. But I don't have these points yet. So I have individual points, but I don't. I need to give it this here needs to be a list. Or so basically, that's where my list skills come into play. So I'll create a list called points, which will be an empty list, and I'll create this point here. So I will create individual point here using these coordinates, and then I'll say points. So that's now the list dot append. I will add a point inside. So this is basically exactly what we were doing now just before in Colab. There's an empty list, which I just call points. I can call it whatever I want. So I can always give it the name I want, but I usually always give it a name that somehow refers to what is inside the list, because that, of course, helps me keep track. And I use the append, which is a Python function to add elements to this list. And I already created individual point objects, so I can just append them. I can just add them to this list. And just to show you now a little bit how this list looks like, so I don't even need to add these points in between. There's a difference between this point object here and the kind of, when I say rs add point, then the Rhino is just drawing it in Rhino, but I can actually create a sort of a point object without drawing it in Rhino if I don't need to. So I can say print here. Let's see how these points look like. If I run it, okay, the Rhino is just printing out a very huge list, which says this points list now contains these. It contains Rhino geometry point 3D object, and this is kind of the position in the memory, and it even gives me like a small preview of what are the coordinates of that pointer here. And there should be 1,000 points inside, so this list is very long, and I don't really care how this list looks like. It's just important that it contains all of my points, or so I don't really need to print them. But I can use this function called rs add polyline. This function here says I need to give it points, which is a list of 3D points. Okay, so here duplicate consecutive points will be removed. Okay, the list must contain at least 2 points. Okay, that's it. So if I run add polyline, now this polyline will be added to the document. Oh, it's very fast. Okay, and of course it's let's do it kind of again. If I run it, so that's basically now my sort of a random three-dimensional line. So this is one line, and it's connected, and it's of course not really self-intersecting because these lines are probably not intersecting. They cannot really intersect probably because they are because of the kind of tolerance, but they maybe bypass each other quite close. And if I want to see it a little bit better, I can pipe it in Rhino, or so I can just say here pipe diameter maybe 1 is fine. Let's see how it looks like. Up, and let's see how it looks like. So now the pipe this going to be the Rhino will just add a pipe around it. Hope the radius is not too big. Oh yeah, maybe. Okay, and here I can go in a different preview, maybe shaded or maybe Arctic. But this is not really a random walk. Okay, this is just bounding box with random points. Okay, so this is bounding. One of them came out. That's interesting. I think that's just a little bit how these pipes were created. Something is a bit off here. It should not come out. But I think it's just maybe how the points are created. So this is not random walk. These are basically, this is a collection of random points which are connected with the polyline and then piped. Or so that's the kind of that's the result. Okay, here you can even see the polyline here. I guess sometimes it kind of breaks. Let's actually do it with a bit less points, so maybe 100. I think Rhino will like that. So let's just run it. Hop, it's a bit better. And I can just pipe this. Okay, so that's a little bit kind of better. Okay, but again, this is not random walk. This is just a randomly connected point. So we will try to do a random walk as well. But for that, we need to do a small modification. What the random walk is basically, if I look kind of from the top here, random walk is, I have kind of a step that is more or less always the same, or it is a step that is kind of constrained. So the step cannot be very large, but it's very small, maybe, has maybe a fixed length. And then I'm just choosing a random direction, or that's a random walk. And that's, of course, that's basically Brownian motion. Or so if you put pollen in a cup of water, the pollen will move in this way because its pollen is very light, like the plant pollen or the plant seeds. They are very light and they're kind of being pushed literally by agitated molecules of water in different directions. And that's a little bit also how kind of the water molecules will also kind of move in a liquid. Of course, there are many of them and they all collide and so on. And that's called Brownian motion. And it's in a way directly related to random walk, which is sort of a particle. Sometimes it's also called a drunkard walk, or so it will just kind of go around in random directions, some bound step, okay? And we'll try to do this with code, and we'll get something that looks a little bit similar like this, but actually different, or it will just look different because these steps are then kind of smaller. Big steps are not allowed. And to do that, we need to modify this code just a little bit. So not too much, just a little bit. Okay, this is a random polyline, and I will now say random walk. Okay, so what are we going to modify? And yeah, I see that we have only 10 minutes left, so I think this is going to be the, we'll kind of end with this example maybe. Okay, so we have random walk. We are here getting a random point, and that's okay, but we actually want to create a random vector. Okay, at the very end, we're going to create a polyline, but only at the very end. We have 10 steps, sorry, 100 steps here. Okay, so we are going to create not a random point, but we're going to create a random vector, and I can just call it here ranvec, or let's call it, yeah, ranvec. It's a random vector. And Rhino geometry has, same as it has an object type for points, it has an object type for vectors. So rg.vector 3D. So this point 3D and vector 3D, this we will use all the time. So don't worry about it if I'm kind of now introducing them and kind of wondering, oh, where did he pull it out? So we'll use this vector 3D and point 3D and we'll use a plane and that's it. Like, and then everything else will be kind of Rhino geometry, but there are these very few types that we will use, like vectors and points and lines. Okay, random vector is basically the same as random point. And it has, these would be then called components of the vector, not coordinates of the vector. So these are the components, and this is a bit too large. Or so maybe here we can say something like, we can now define certain things, certain variables outside. So we can, for example, say, or let's call it step size. Okay, so there's some step size, and this step size is the step of the walk. So maybe it's 10, maybe it's not 100, but maybe it's 10, maybe it's 1, whatever. And when we are getting a random direction, this x, y, z, we go from minus step size to plus step size. Okay, so it can go in the minus direction as well. So we can get a random number here. If we can get also a negative number here, and this is important because if you just use positive numbers, then our walk will be biased. It'll kind of tend to walk toward a positive quadrant always. But we go kind of from minus to plus. Okay, we get 3 random numbers, and we use them as components of our vector, random vector. Great. And because this is just see. Okay, so now we can use a trick. Basically, we can create a point, which is going to be our origin, and this we will create outside. So I'll just cut this out and put it outside. And let's not call it point, let's call it origin. Okay, so there's origin, which is a point 3D, and let's say we start at 0, 0, 0. Okay, so our origin is always in the kind of middle, or in the origin of the world. And now one thing that I can do, because this is a point 3D and this is a vector 3D, and they're objects and they're kind of sort of smart in that way, I can actually add them together. Or so it makes sense. So because again, these are objects. So if I tell Python to do something like this, origin plus random vector, these two objects, I can add them together. I can do it because this library, this Rhino geometry, gives me this option. So it basically inside here, it says, if I kind of add this object and this object together, so point and vector, I add them together, this library Rhino geometry, it knows what to do with it. And it makes sense for us to add points and vectors because this just means that I'm translating the point. Or so this is in a way where you can really profit from using these inbuilt objects. Also, these are not just simple variables, but they are smart in a way that if I say add them together, the library knows what to do with them. So I can say some kind of a, well, I guess this would be kind of a new origin. So new origin equals old origin plus a random vector, which means that this origin will be now translated in the direction of this vector. Okay, and then I'm going to add this new origin to the. I'm going to add the new origin to the points list, and then because when I'm doing the walk, I want, I translated a point, great, and now my next starting point, my next origin needs to be the origin the new origin that I just defined. Or so I'm not starting from the center always, from the origin, the kind of origin of the world, but I'm always starting to walk, of course, from the sort of previous point that I reached. In order to do that, I need to now define. Oh wait, discarding local changes. Reload now. Okay, save this. So I just have to do a small trick here. I have to basically say, well, now my old origin equals the new origin. I think that's correct. Okay, so the origin that I used before is going to be rewritten, and it's going to become this this new origin. Also, this way I'm ensuring that in the next step, I'm always using the origin that I created last. Okay, so this is important. Otherwise, I will get kind of a mess, or all the points will. Well, you'll see what happens if I remove this line here. And this should now work already. So this should give us some random polyline. Let's see. I hope this works. Oh, perfect. Okay, I'll just compress some of these things. Just make it a bit smaller. And maybe I do it like this. Okay. Okay, let's do it again. If I run it, I'm getting yeah, I have this shaded. Maybe I got shaded. Okay, so now I have a random walk, and I can maybe just run it maybe 1,000 times, so it's a bit easier to see what's happening. Okay, so now there are actually 1,000 steps, and this is a three-dimensional random walk, which in a way corresponds more or less to a Brownian motion of a particle in some kind of fluid, and it also resembles a little bit of kind of protein folding, because proteins are just chains, and then when they fold, they might kind of look a little bit like this. So I can just try to pipe this. Let's say pipe up, 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 enter. Okay, and I can go here under Arctic preview. Okay, just actually make it bigger. Okay, so again, this is just this is just a little bit of a sort of this pipe didn't really come out well. So sometimes when the angle is too steep, you get this sort of weird, you cannot really close it. So yeah, these are also very steep here. Okay, so when you have a very steep turn, then the Rhino pipe cannot kind of close it. But this is an object. Now, if you would want to just model this in Rhino, of course, this is currently nothing. It's just a sort of a random shape. But already, if you would want to do this in Rhino, like just to model it, this might be a bit hard. So without code, it's basically, I wouldn't say it's impossible to do, but you cannot really do this. It's very hard to just model this in Rhino. Or so you basically need to know a little bit of code in order to create shapes like these. And again, these are not really anything yet, but this is just a start. Okay, so if I run this over and over, we are getting a different polyline. Or so I can just actually delete these ones. Yeah, okay. I have a problem with the preview when I'm in this Arctic mode. Okay, so this is just being kind of added. And random walk, great. And then I just want to show you one last thing. I didn't really talk about random seeds, but basically these random numbers that we're getting are they are pseudo-random numbers, or so they're actually determined in a they're generated in a deterministic way, meaning I can actually fix the way that they are created. And I can do this by generating the random seed. So now when I run this code, I'm always getting a different polyline. Also, there are like different ones here. They kind of overlap, but they are actually all different. But I can actually fix the seed, or there's a random library, has a function called seed. And in the seed, I can put whatever I want. So it can be, says here, initialize the internal state of the random number generator. It can be whatever I want. So I can just put here, random seed. So I just kind of wrote it as random seed. And now when I run this, I'm also getting a result. But when I run it again, I'm getting exactly the same sequence of random numbers. So I actually got two lines that are exactly the same. So it's a bit hard to see, but these two lines are exactly the same. So they're kind of pseudo-random, or so I can sort of fix the level of randomness. That's it. So that's a little bit important to understand, that we talk about randomness, but we actually mean pseudo-randomness, because if you fix the seed at the beginning for a different seed, I will get a different result there. So I can change something here. I can say, for example, random seed 2. If I run it, now I will get a different result. Now this result is different, it's because I changed the seed. If I leave this code out, then the seed is in a way determined it's funny, but it's determined in a random way. So the computer is somehow deciding what this number is based on some internal states, maybe reading the microphone, or so it basically creates a random number, which then determines the random seed for the random generation. But I can actually fix this seed, and this is useful because sometimes I want to have a random process, but I want to get the same random process when I run the simulation. So sometimes if I run a simulation, it's useful for me to kind of fix the randomness, because I might want to check what will happen if something, if in this process something happens in the middle. I want to see how the system is kind of deviating from its trajectory. So sometimes it's good to sort of fix the randomness of the system. And yeah, and you can imagine that if you're, this is of course relevant for password generation, for gambling machines. So these seeds have to be well controlled, well hidden, otherwise they can be exploited. Okay, but basically these are pseudo-random numbers. Do it one more time. Okay, so that's it. That's a little bit kind of what I wanted to show you today. randomness, random walk, and then kind of just this first step of generating geometry. So connecting kind of Python and Rhino and how you can do that.